Are you looking for solution architect interview questions or cloud architect interview questions? If so, this video is for you. Hi, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects. And we're an organization that's dedicated towards building high-performance cloud computing careers. Personally, I've been working in technology for over 25 years, and I've been coaching others or mentoring others to get their first tech job or get promoted in tech for over 2 decades. Today, we're going to talk about preparing for that cloud architect interview or that solutions architect interview. And we're going to do so by giving you some solutions architect interview questions or cloud architect interview questions. Now, when you're asked these interview questions from the hiring manager, they're asking it for a few reasons. First, and obviously, they're trying to check your technical competency, but they could do that in a lot of different ways. The reason they're going to ask you a lot of open-ended questions is they want to not only see your technical competency, but your ability to describe technology, your communication skills, as well as to see how you act under pressure. So what's the best way to act under pressure? Be prepared for the pressure in the first place. If you're prepared, it'll be a review when you're there, not the first time, so you won't be stressed. So that's why we have these videos on cloud architect interview questions, to make sure you're successful on that cloud architect interview or that solutions architect interview. The first question that we're going to ask you is to describe the 4 types of disaster recovery options in the cloud and the strength and the weaknesses of each approach. So first, obviously, you need to know the 4 types of disaster recovery options on the cloud, and then you need to know the reasons why an organization would choose each. So let's walk through that together. The first disaster recovery option is just simply backup. Let's say you're on a cloud provider or your data center. You take an image of your servers and you move it over to the cloud. You back up your data and you back it up to the cloud, and maybe you say once per day you take your data from the cloud and you your data center, and you synchronize it with the cloud. That's it. That's backup. What's great about this? You back your data up to the cloud. It's very cheap. And if you needed to get the organization's systems up and running, within about 12 hours you could do it. The organization is completely up. It's been a wonderful, low-cost, high environment way to do disaster recovery, high reliability, and extremely low cost. Okay, so let's talk about the next time. In the previous version, we talked about copying your data and synchronizing, and say every 24 hours. So the next version would be to keep our data synchronized a little more frequently. But not all data needs to be synchronized a little more frequently. So let's talk about how we can do this. In disaster recovery version 2, we're going to take the same images of our servers as we did previously and move them over to the cloud. We're going to back up our data, say every 24 hours, and move that to the cloud. But in this case, we're going to keep a database synchronized between, say, our data center and the cloud. And by keeping our databases synchronized between, say, the data center and the cloud, guess what? Now our transactions are synchronized in both cases. So if there's an outage in our main environment, say our main data center, we go up and running on the cloud. It's still going to take us about 12 hours to come up, but our transactions are synchronized, so our data is fresher. So it's an improvement over disaster recovery option 1. The next form of disaster recovery, or disaster recovery option 3, the cloud really shines here. And this is because the cloud has auto scaling. So disaster recovery option 3 really revolves around auto scaling. And what this method is in your data center, you've got your actual real environment, and you create a replica environment in the cloud. Meaning if you had a network load balancer and 100 web servers in the data center, maybe you set up a network load balancer or 2 and 2 web servers in the cloud in an auto scaling group, so that can scale out as needed. And say you do this for all of your environments. Then here's what happens. If anything happens in your data center, traffic will be redirected to the cloud, and all your systems are running in the cloud, and they're all synchronized, but they're in auto-scaling groups and they're small. So all the traffic would be redirected to the cloud would auto-scale, systems would scale out, and in about 45 minutes to an hour, the cloud would be a perfectly operating, fully established disaster recovery environment for the organization. So Disaster Recovery 3 is really amazing. It provides high-speed, high-performance failover for disaster recovery, and it does it at a relatively good cost by leveraging small instances of everything on the cloud, a replica environment, and using auto-scaling. Now, the last form of disaster recovery is the pure active. And here's what this does. If you've got an organization that's got 1,000 web servers in their data center, you're going to have 1,000 web servers in the cloud. If you have 1,000 app servers in the data center, you're going to have the same 1,000 app servers in the cloud. It's just going to be a mirror image. And if anything goes wrong in the data center, the traffic will just get redirected to the cloud and everything's running. So what have we got? We've got backup. We've got backup plus synchronizing our databases. We've got a small instance version on the cloud using auto-scaling, and we've got a complete active, hot environment. Those are your 4 types of disaster recovery options on the cloud. The next question we're going to ask is a networking question, and it's a really important question. Most of what we cloud architects do is we take systems from the network and the data center and we migrate them over to the cloud. Now, what are we migrating? We're migrating data as well as systems. And the way we get those data or systems to the cloud could be one of a few ways. If we've got a private line or a direct connection or a VPN, we can just transfer it over. But if we don't have enough capacity on those lines, or we have too much data to transfer and not enough time, we might need services such as the import-export service, the snowmobile, or the snowball, and the capacity and how much data we're going to have to transfer is going to be there. But you're never going to know this if you don't know the capacity of your link. So the next question is, how much data can you transfer in 24 hours on a gigabit Ethernet link? So I'll say it again. How much data can you transfer in 24 hours on a gigabit Ethernet link? So you will see this on exams like the Certified Solution Architect Professional, but you will see this on interviews. So how do we determine this? Well, we know that a gigabit per second is 1,000 megabit per second. So we also know that there are 8 bits to a byte. So let's do this first. If we take 1,000 megabits per second, because it's megabits, we first convert that into bytes. So we take 1,000 megabits, divide by 8, and now we know we can transfer 125 megabytes per second. Well, there are 60 seconds in a minute. So if we take our 125 megabytes and we multiply times 60, we know that we can now transfer on this link 7.5 gigabytes per minute. Now there's 60 minutes in an hour. So if we take 7.5 gigabytes, which is the amount of data we can transfer in a minute, times 60 minutes, that equates to 450 gigabytes per hour. Now there's 24 hours in a day. So we take our 450 gigabytes, multiply times 24, and we get 10.8 terabytes. So we know, at least theoretically, we can transfer 10.8 terabytes on a gigabit Ethernet link. Next question. Why can't we get the full 10.8 terabits on a gigabit Ethernet link? Now this is where we're asking your networking knowledge. So what we're looking for here is we want to know that you know about the way the network works. Meaning, just because we have a gigabit doesn't mean we can get it. So for example, if there's TCP and there's flow control going back and forth and acknowledgements, that will cost us bandwidth. But when we take the packets or when we take the data and we put an Ethernet frame on there, the Ethernet frame as a header adds overhead. Then we slap an IP header on there for the TCP IP networking, and that has overhead. We might actually have a VLAN tag or something like that, and that also adds overhead. So the reason we will never get maximum performance on our link is due to the overhead and the encapsulation methods of Ethernet IP, in other words. So there's always going to be about 5 to 10% overhead on a link. So now you know why you can't get the full utilization out of a link, because there's overhead on a link. It's the same reason that if you have an 80 terabyte hard drive and you format it, you might only get, say, 72 gigs in capacity, like an AWS Snowball, because of the overhead associated with it. In this next question, we're going to talk about 3 kinds of storage. When do you use object storage, when do you use block storage, and when do you use file storage? First, let's talk about object storage. You should be able to tell the employer that object storage is a type of storage area network that's very unique in the way that it operates, and that it takes data and breaks it down into objects, and that each object has metadata or data about that object. And because each object has metadata about that object, it is very easy to search, very easy to query, and can integrate really well into a big data environment. You should also be able to tell the employer that object storage is not regular storage, in that it does not get used by computer systems like regular storage, that object storage is not suitable for regular computer systems because anytime something is modified even a little bit, it would create a new version. And that's why object storage could not be used as like a hard drive where there'd be a swap file or an operating system or anything that would constantly be changing. You might also want to be able to say that object storage is really more like a database, and that it's not hierarchical in nature, and basically the data is just placed into object storage, and there's like a database pointer that points to the location of the object storage. You might even want to be able to tell them that object storage is used for software distribution, it's great for backup and archival purposes, and it's great for data lakes. So that's what you realistically want to tell them about object storage. You could also call it S3 if you're dealing with AWS. You could also call it cloud storage if you're on the Google platform that day, and you could also call it blob if you're on Microsoft. But realistically speaking, what we're just talking about is object storage. The next type of storage is block storage. Now, block storage is another type of storage area network technology where data is broken down into blocks. Now, what makes block storage so good for the cloud providers is it effectively enables you to place the storage environment or the blocks anywhere it needs to be in the storage environment. So by doing so, it effectively decouples your compute from your storage. So that's why your cloud providers are using block storage. Now, block storage is network storage, so it's not going to be as fast as local storage, and its speed is going to be limited, and its throughput is going to be limited by the network, the type of network you're using. So if you're limited at 1 gig or 10 gig or 100 gig, that's going to be the limitation of performance that you're going to get from your block storage because it's network storage. Now, also be able to describe that block storage looks and feels when it's mounted just like a hard drive. So block storage is used in the cloud computing environment when an organization needs something that would function as a virtual hard drive. Why do the servers in the cloud need a virtual hard drive? Because the servers come with basically the storage as part of it. It could be called instant storage, it could be called ephemeral storage. Basically what that means is the storage that comes on your virtual machines, which is very fast, goes away with system reboot. So if you're going to have a server in the cloud and the server is going to need to have anything that's stored on it, you have no choice. You're going to use block storage because you can't store it on the instance itself. So that's why organizations use block storage, and that's why cloud providers use block storage, because it scales so well. The next type of storage is really network file storage. And there's really two kinds of network file storage. If we're dealing with Unix and Linux systems, we're really dealing with some version of the network file system that was invented by Sun Microsystems, now Oracle, a while back. Or we're dealing with some form of server message block for a Windows system. So if we're dealing with AWS, for example, we're going to have two options. We're going to deal with their version of NFS called the Elastic File System. And we're going to use the Elastic File System when we've got a bunch of Linux and Unix servers that need to look at the same information. They're all going to mount a shared drive. And that's why we're going to do that for our Linux and Unix systems. So shared information used by lots of servers. We're going to use EFS in the AWS cloud, NFS in the data center. Now, let's say we've got a lot of Windows systems. Well, we could obviously set up a server and run Samba on it, but if we're in the AWS cloud, they've got FSX, which is Windows servers that are basically a fully managed file system for Windows, so basically Windows file servers. So those are the storage options you have in the AWS cloud and the purposes for each one. Now, this next question is going to be on DNS. And we're going to base it on the AWS flavor of DNS today, and we're going to say, describe AWS Route 53 and the main routing policies and what they do. So first, you need to know that AWS's brand, or the Amazon brand of DNS, is called Route 53. Interestingly enough, DNS is TCP and UDP port 53. So you also should know that DNS basically maps a name to an IP address in its overall function. basically giving you a name like www.gocloudcareers, which is real easy to remember as opposed to its IP address. So now let's talk about the types of routing. So the first type of routing is simple routing. This is the first type of simple routing policy. What this is we map an address to a name. www.gocloudcareers.com mapped to whatever its IP address is. Simple routing. The next type of routing policy with Route 53 is the failover routing policy. This is quite simple. We've got 2 data centers, or 2 servers somewhere. Send your data here. If this goes away, send the data here. So just go to the primary doesn't exist, go to the secondary. That is failover routing policy. Here's what happens, the systems send a health check. Basically DNS is here, and it says a message, hey, are you there? Are you there? Are you there? And the data center says, I'm here, I'm here, I'm here. And as the DNS keeps sending a health check saying, are you there? The data center says, I'm here. If, for example, the data center stops responding to health checks, are you there? Are you there? Are you there? No response. Data is shifted over to the backup data center, and that is failover routing policy. Now, the next policy we're going to talk about is geolocation, and geolocation is really cool. Geolocation will route traffic based upon the location of your users. So, what is geolocation routing? I leave my house in Florida. I go visit my family in our village in Greece. I'm in my village in Greece. I go to connect to the internet and something amazing happens. I connect to the internet and I want to go to a page and it sends me to a page with Greek writing all over it. What happened? What happened is geolocation routing policy. Geolocation routing policy is I go to a country. It looks at my source IP address. By my source IP address, it knows where I am, where my location is, and then it sends me to the closest website, for example, based upon my IP address. So if I'm in Paris, I'll get sent to a French website. If I'm in the Middle East, I might get sent to an Arabic website. It is really cool. Figure out your source IP address, figure out your source country, and then route you to a different load balancer. So for global organizations that might have an Arabic web page and a French web page and a Spanish web page and an Italian web page and a Greek web page and a Mandarin web page, how neat is it that you can be able to figure out who the user is by their source IP address and then send them to the best page for them? That is geolocation routing, and it is cool. Now there is another geography-based routing option that you have, and that's going to be called geo-proximity routing. And realistically speaking, you're going to use this when you want to route traffic based upon the location of your resources, but have a little bit of control where you're sending your data. So that's realistically speaking the geolocation routing policy. It gives you the ability to modify the size of a region and shift your data from point A to point B. Now let's talk about some other much more commonly used ones. Latency-based routing. Here's what latency routing is. When a user goes to figure out the website and it hits the DNS server, it will determine what region they're in and what's closest to them, what has the lowest latency, and it will send them to the environment that has the lowest latency, which is going to give the best user experience. The next one is called multi-value answer routing policy. And the multi-value answer routing policy is kind of this random policy. Basically speaking, you've got a couple web servers, and multi-value answer will just basically route randomly to whichever one it feels like at the time. Interesting, random. Generally speaking, if you can engineer things ahead of time, that's generally a good thing. So most organizations do not use the multi-value answer routing. Instead, they have a policy, but it's good to know that you have that option. The last option we'll talk about, and this is a great option, is called weighted routing policy. And weighted routing enables you to load share. Maybe you want to send 50% of your traffic to one place and 50% to another, or 70% or 30%, or better yet, you've got your old website and it's running great, everything's good, users are happy. Your team makes a new website, but you don't want to lose your old website. So with DNS, you send 90% to your old one and 10% to the new website, and you get feedback. The new website works, it's great, it's great. Then you shift another 20% over to the new website, and then you shift everybody to the new website when you know it's good. Weighted routing, perfect opportunity for new websites, way to test new applications. So, AWS DNS flavor is Route 53. We talked about simple routing, we talked about failover routing, we talked about geolocation routing, geo-proximity routing. latency-based routing, multi-value answer routing, and of course, weighted routing. Today we talked about the disaster recovery options. We talked about data transfer speeds. We talked about overhead on the link. We talked about storage and why it's used on the cloud. And we talked about DNS routing policy. Thank you so much for watching this video. I look forward to seeing you in a new video very soon. Take care. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. Once per week, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I have known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you to all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architects.